I'd like to welcome you all back to my 7th video, and today I just want to extend our knowledge a little bit of molar mass and move into something called percent composition, which I think is a pretty easy topic compared to some of the ones we've already done together. It's in section 6.6 of your book, and what I want to do here is start with water, because water is such an easy compound to wrap our heads around, and then look at some more complex molecules and figure out how do we figure out the percentage of each element in a compound mathematically without stepping foot in a lab. So here we go. We're in section 6.6 of your text if you're reading along, and it's good to have a calculator and, of course, like I always say, your periodic table. Okay, percent composition. Well, let's start with water. We've already looked at water in the past. So here's my graduated cylinder. And when you look at it, we know that water contains 2 hydrogens and 1 oxygen. And a younger student in grade 9 might say, well, if I were to compare the percentage of hydrogen and oxygen, because there's 2 parts hydrogen and 1 part oxygen, one might say that it's probably 66.66 repeating percent hydrogen by mass and only 33.3% oxygen by mass. And that does make sense intuitively, but guess what? It's wrong. So let's take a look at how we really find the correct percent by mass of water. Well, it's very easy, because we know that the percent of anything is equal to the part over the whole. And we do this all the time, if you think about it. When you get a test back, for example, if you got 16 out of 20 on that test, the part is 16 and the whole is 20. Mathematically, 16 divided by 20 times 100 gives you a mark of 80%. Not too shabby. We can apply the same principle to chemistry. And let's take a look at water. Well, we know that the molar mass of water is 2 times 1 for the hydrogens plus 16 for the oxygen, which gives us 18. And obviously the percent of hydrogen would be equal to the part, which is due to the hydrogens, which ends up being 2 times 1, which is 2 of course, over 18 times 100%. That gives us about 11.2% of the mass due to water, in water due to hydrogen, is only 11.2%. A far cry from that 66.6 repeating that a younger student might just say is correct. So that's hydrogen. Now, how do we figure out the oxygen? 2 ways. Number 1, you can do it mathematically, or number 2, you can say, well, if the hydrogen makes up 11.2% and there's only 2 elements present, it makes sense that the rest of the compound must be due to oxygen. So once again, you do your mental math. 100 minus 11.2 is 88, roughly 0.8%. But don't trust short chemists, like I always say. Let's do the math. So here we go. The percent of oxygen in water is equal to 16 divided by 18 times 100%. And if you have your calculator handy and you do the math, lo and behold, that ends up being 88.8% oxygen. So this is a fairly simple concept. And the fact is, if we take a sample of water, like this one, from Norfolk County, and we compare it to a sample of water in Beijing or Moscow or Paris, France, all those samples, assuming they're pure, will contain the same percentage of hydrogen by mass, which is 11.2, and the same percentage of oxygen by mass, which is 88.8. this gives us a very important law, which we call the law of definite proportions. And it's very straightforward. It just states what I just iterated. The percent of elements in a compound is constant. That's really all it is. It doesn't matter where we get the water from. Assuming it's pure water, the percentage of hydrogen would always be 11.2 and the percentage of oxygen would always be 88.8. All right, let's take a look at one more example. Here's a question. Let's find the percent composition of calcium phosphate. So a little bit of review of nomenclature. Remember, this is the material found in our bones, right? Calcium is 2+ and phosphate is 3-. That's how we get this fairly complicated formula. What are we going to do? We're going to look at each element individually. So we have to look at the calcium, we have to look at the phosphorus, and we have to look at the oxygen. First thing we have to do, just like we did over here, is to figure out the molar mass of calcium phosphate. Now I'm going to do that quickly because I've already done it millions of times. You can run it through in your calculator. Just trust me in this case that the molar mass of calcium phosphate is 310 grams per mole. If you're struggling with that, go back to a previous lesson and it'll help you with that. Now we look at the percent of calcium in this beast. Ends up being there are 3 calciums and each one has a molar mass of 40 if you look it up in your table. So 3 times 40 divided by 310 times 100% will give us the percent of calcium. And again, I've already done the math on this. It ends up being 38.7% calcium by mass. Pretty straightforward. Again, the percent of the element is equal to the part divided by the whole times 100%. Just like the test out of 20. Let's continue. If you look at this formula, notice that that too belongs to the phosphorus and the oxygen. So there are 2 phosphorus atoms. We got to be careful with that. Therefore, each phosphorus has a mass of about 31. We're going to round that. So we have 2 times 31. Our whole is still the same. Multiply it by 100%. And you can see that this number is a little less than the calcium was. Again, I've done the math. It is about 20% phosphorus by mass. So now we've taken care of 2 of the 3 elements in calcium phosphate. There's the calcium taken care of at 38.7 and the phosphorus taken care of at about 20. The only one left is the O. So I can look at this and say, well, I've got 38.7 here and I've got 20 here. Takes me to about 58.7. Therefore, the remainder, which is a little more than 40, I guess 41.3, should be the O. But let's do it. The percentage of oxygen, in this case, would be equal to 8 times 16 divided by 310 times 100. And if you go through the math on that, you will get the number that we expected to get, is 41.3% oxygen. Now, the good news about these kinds of problems is you can check to see if you've done it correctly. Because if there's 3 elements in the compound, and those percentages add up to 100, or close to it, because there could be a small round off error, you know you've done it correctly. And there we have it. That is a good short lesson on percent composition, section 6.6 in your textbook. And the next visit will involve looking at something different called empirical formulas and molecular formulas. But this is our first step to take our moles and start looking at them in terms of percentages. The law of definite proportions tells us that no matter where I get that bone on the surface of the earth, it'll have those percentages of those elements.